In this video, I will look at HDMI. HDMI is a standard for transferring data over a cable which has become very popular and is used with TVs, monitors, cameras, and computers. It is essentially used just about everywhere. This video will help you understand what it can achieve and how you can use it. High Definition Multimedia Interface, or HDMI, is a proprietary interface used to transfer data, first published in 2003. HDMI uses 4 different types of connectors. The standard connector has 19 pins and is the most commonly used connector. You will find this used on most products. The dual link connection has 29 pins. The extra pins double the number of data lines that can be used to transmit data. The dual link has never been used in a product before, but it could significantly double the amount of data a device could transmit. As we will see later in the video, the standard connector provides a lot of bandwidth already, so we may never need the dual link connector. Although potentially dual link could increase the bandwidth, this would also mean the addition of a different device connector. It seems logical that when you have a standard connector that can transmit a lot of data already, manufacturers did not see the need to complicate things by adding the dual link connector when the standard connector was performing well. As we will see later in the video, the standard connector bandwidth keeps increasing in speed, so I think it will be unlikely that we will see the dual link connector used in the future, but you never know. The mini and micro connector versions have the same number of pins as the standard connector. However, the pins are connected in a different order than the standard connector. These connectors are designed to be used in small portable devices. HDMI uses serial communication to transfer data. It does not use differential signaling like many other cables. Rather, it uses a clock signal to keep data lines in sync. This method is called Transition Minimized Differential Signaling, or TMDS. To send 8 bits requires 10 bits to be transmitted. The 2 extra bits are used to correct clock skew. Essentially, clock skew is when the data lines get out of sync with each other. Having these extra bits allows HDMI to work out if clock skew has occurred and correct it. This becomes important when the transmission rate increases. It also helps HDMI to run longer cables and helps make them cheaper to manufacture. HDMI has become very popular with many devices using it. It comes in a number of different versions, and each version supports different speeds and options. HDMI version 1 was released in 2002. It is based on DVI architecture, which was a popular connection for video before HDMI. Since it is electrically compatible with DVI, it is a simple matter to use a DVI to HDMI passive adapter. One of the design goals of HDMI was to make it compatible with DVI, but to extend its limitations. HDMI will support the DVI resolutions with one exception. It is digital only and will not support analog signals. DVI was able to support analog signals like VGA. However, HDMI will not be able to support older analog signals like VGA. In order to do this, you will need a device to convert the signal from analog to digital, or an active adapter capable of converting the signal. The maximum resolution is 1080p at 60 Hz, which matches that of DVI single-link maximum resolution at 60 Hz. When looking at HDMI, it is important to understand the transmission rate. Different cables will have different limitations on how much data they can transmit. This will affect the resolution you can run at, the frame rate, and the number of bits that can be used for each pixel on the screen. In the case of version 1 of HDMI, it supported a transmission rate of almost 5 gigabits per second. It should be remembered that HDMI uses extra bits when transmitting, so effectively, the amount of actual data it transferred per second was 4 gigabits per second. Effectively, almost a gigabit per second is lost for extra control data to ensure data accuracy when transmitting. The next feature that HDMI adds is audio support. DVI does not support this, so if you use an adapter, remember that you will lose any audio from the signal. The last feature that HDMI adds is Consumer Electronic Control, or CEC. CEC is the ability for one HDMI device to control another. For example, if you have multiple HDMI devices connected together, you could potentially have the one remote control to manage them all. Essentially, CEC allows an HDMI device to send commands to other HDMI devices. This sounds like a great feature, however, there are some problems with it. First, each manufacturer is free to implement it in different ways and may call it different names. CEC is an optional specification for HDMI, so the manufacturer does not need to implement it to be considered HDMI compliant. However, when it does work, it can be very helpful. For example, if you have a device like a PlayStation, when it is switched on, it can send a message to the TV to change HDMI channels. This sounds pretty simple, but consider you have a sound system plugged in between the PlayStation and the TV. The sound system would be required to pass this signal on to the TV. So now you understand how CEC works. Well, at least how it should work in theory. There have been several different versions of HDMI and revisions. However, I will only be looking at the main ones released. Most devices will support one of these main versions. Some of the revisions include additional features. However, it should be remembered that it is up to the manufacturer if they want to implement these features, as a lot of them are optional. Even if they don't implement all the features, they can still be considered as meeting the standard. The next version I will look at is version 1.4. This version was released in 2009. This version added more bidirectional features. Most monitors have the ability to send some data back to the computer. The main use for this is telling the computer what resolution it supports. In the case of HDMI version 1.4, the feature Audio Return Channel, or ARC, has been added. This allows audio to be transferred in the opposite direction than the data would normally be transferred. Let's consider an example of when this would be useful. Let's consider that you have an HDMI DVD player. In order to get good sound, you purchase a sound system. The sound system is connected to the DVD player using an HDMI cable, which will deliver video and audio over a single HDMI cable. Here the video is shown in blue and the audio shown in green. The sound system can now send the audio to its speakers and the video to the TV. So far, the system works pretty well. The problem occurs when we add an antenna to the TV. The problem is that the antenna is receiving video and audio and transferring it to the TV. We want the audio part to go to our sound system. In order to achieve this, normally we need to either have the antenna plugged into another device that plugs into the TV. This device could then redirect the audio to the sound system. Or we connect another cable from the TV to the sound system. To get around this, HDMI 1.4 has the Audio Return Channel, which essentially allows the audio to be transferred, as the name suggests, in the reverse direction to that which the signal would normally be transferred. This allows the sound system to get the audio rather than using an additional cable or having to install additional devices. This is a big advantage because it means less cabling when you start setting up multiple devices together. HDMI 1.4 also adds 100 megabits Ethernet connection support. In theory, all your devices connected will share the same network connection. Sounds pretty good in theory. In practice, it is pretty hard to find a device that supports this feature. The problem is manufacturers want to get their costs as low as possible, so don't want to add features they don't need to. With wireless and other networking being pretty cheap and pretty good, there is not much demand to have this feature. Since wireless does not require any cables anywhere, you can't really use the argument that it will save you running additional cables, since wireless does not require cables. To make things more complicated, you need a special HDMI Ethernet cable in order to use it, so you can see why this feature did not take off. In the case of version 1.4, the usable bandwidth is about 8 gigabits per second. As more data is transferred over the cable, this may limit the maximum resolution of the cable. In this case, the maximum resolution is 4K at 24 Hz. 24 Hz is a pretty low frame rate, so you may want to use a different resolution like 1080p, which supports up to 120 Hz. Which resolution you choose will determine how much bandwidth is required. With version 1.4, additional color support and 3D support has been added. The color support also includes color support that uses less bits, so if you reduce the color mode, you may be able to increase your resolution or frame rate. In 2013, version 2.0 was released for HDMI. The main improvement is that bandwidth has increased. The bandwidth is effectively 14.4 gigabits per second. This allows for a maximum resolution of 8K at 30 Hz. However, to get this, the color depth has to be set at its lowest setting. The more commonly used resolution would be 4K at 60 Hz. If you are planning on running a resolution like this, anything that is not HDMI 2.0 compatible or not set correctly will cause HDMI to drop down to a different version. For example, your video card, cable, and monitor will all need to support HDMI 2.0. Also, problems can occur when something is not configured correctly. For example, if the monitor is configured for HDMI 1.4, the monitor will use that version. You may need to adjust a setting on the monitor to configure it for 2.0. Some monitors will ship with the default setting configured to a lower setting for compatibility reasons. If you find your frame rate is very low or your maximum resolution is limited, you may need to change the settings on the monitor. HDMI 2.0 increases the number of audio channels from 8 to 32. For home use, you probably would not go above 7.1 surround sound. But if you did decide to go to 11.1 surround sound or higher, HDMI would be ready. The last feature I will look at is Dual View. Dual View allows two video streams to be sent via the same HDMI cable and be displayed on the same screen. This is potentially useful for systems like CCTV, where you may want to show two different video streams on the same screen. The last version I will look at is HDMI version 2.1, released in 2017. The big change with version 2.1 is that the clock signal was removed to provide an extra channel of data. In order to take advantage of this, it does require a special ultra-speed cable. The specification is backward compatible with the older cables. However, if you use the older cables, you will get a slower speed. HDMI 2.1 is able to achieve an effective transmission rate of 42.6 gigabits per second. This is achieved by increasing the speed the data is transferred and removing the clock signal. Previous versions of HDMI used 3 wires for the clock signal. These wires have been changed to a data channel rather than a clock signal. Adding an additional channel effectively means that a quarter more data can be sent than before. In order to provide the timing for the cable, HDMI uses differential signaling, so essentially the clock signal is part of the data signal. So this is the same technology that is used for other high-speed communications like PCI Express and high-speed USB. To increase the speed even more, the encoding is changed to sending 18 bits for every 16 bits of data. This effectively decreases the overhead, meaning that you can send more data. With this much data, HDMI 2.1 now supports 8K at 30 Hz. It is possible to get a higher frame rate than this at 8K, but to do this requires the hardware to support compression called display stream compression. You can see that with this kind of speed, HDMI 2.1 will be in use for quite some time to come. HDMI 2.1 does add some other features, the most noticeable of which is variable refresh rate. If supported, this allows the frame rate of the screen to be adjusted. This covers it for HDMI, but before finishing this video, I will quickly compare it to DisplayPort to give you an idea of what the main differences between the two are. There are a number of different versions of DisplayPort, which I won't go through, as I will leave that for the DisplayPort video. If you have a similar version of HDMI and DisplayPort, all things considered equal, about 90% of the features for each are the same. There are some things which are different, and this may affect which one you choose. DisplayPort is royalty-free, unlike HDMI where a royalty needs to be paid each time it is used in a device. DisplayPort plugs have small locking clips locking the plug in place. HDMI does not, so they can more easily be knocked or accidentally pulled out. DisplayPort supports old standards, including VGA. You will, however, need a passive adapter for this. Given how old VGA is, I don't think this will generally be a problem, but the feature is there if you should need it. HDMI was designed primarily looking at home devices, while DisplayPort was designed primarily for computing devices. For this reason, it does not support features like consumer electronics control and audio return channel. These features are good features to have for a home system, but for computers are not really needed. DisplayPort, however, does have an auxiliary channel which allows data to be transferred in the reverse direction, as ARC does. DisplayPort, however, does have support for multiple monitors from the one DisplayPort. So you could use one DisplayPort connection to your computer, plug it into a DisplayPort hub, and run 3 independent monitors for the one DisplayPort connection. This feature alone is one of the big reasons why people go for DisplayPort rather than HDMI. If you are looking at a home entertainment system, you will most likely use HDMI. This concludes this video for IT-free training on HDMI. I hope you found this video informative, and I look forward to seeing you in the next video from us. Until next time, thanks for watching.